This is one of the great questions. How many advanced civilizations capable, at least of radio astronomy, are there in the Milky Way galaxy? Let's call the number of such civilizations by the capital letter N. It's a number. It depends on many things. It depends on the total number of stars in the Milky Way. Let's call that N sub star. It depends on the fraction of stars that have planets. Let's call that F sub p. It depends on the average number of planets in a given solar system that are ecologically suitable for life. Let's call that N sub e. It depends on the fraction of suitable planets in which life actually arises. Call that F sub L. Depends on the fraction of inhabited planets on which intelligence emerges. Let's call that F sub I. And on the fraction of those planets in which the intelligent beings evolve a technical communicative civilization. Call that F sub C. Finally, it depends on the fraction of a planet's lifetime that's graced by a technical civilization. Call that F sub L. If we multiply all these numbers together, we've estimated capital N, the number of civilizations. This equation, due mainly to Frank Drake of Cornell, is only a sentence. The verb is equals. So let's try to go through the program of this equation. By carefully counting the number of stars in small but representative regions of the sky, we find that the total number of stars in the Milky Way is about 400 billion. It's a lot of stars. What about planets? Well, in studies of double stars, in investigations of the motions of nearby stars, and in many theoretical studies, we get a strong hint that many, perhaps even most stars, are accompanied by planets. So let's take F sub p, the fraction of stars that have planets, as a quarter. Then the total number of planetary systems in the galaxy is 400 billion times a quarter, or 100 billion. We'll write down our running totals in red. Now, if each system were to have, say, 10 planets, as ours does, there would be 100 billion times 10, or a trillion worlds in the galaxy, a vast arena for the cosmic drama. In our own solar system, there are several bodies that might be suitable for life of some sort. There's the Earth, of course, but there are possibilities for Mars, for Titan, perhaps for Jupiter. If other systems are similar, there may be many suitable worlds per system, but to be conservative, let's choose N sub e equal 2. 2 worlds suitable for life per system. Then the number of planets in the galaxy that is suitable for life would be 100 billion times 2, or 200 billion. Now, what about life? Under very general cosmic conditions, the molecules of life are readily made. They spontaneously self-assemble. It's conceivable that might be some impediment, like some difficulty in the origin of the genetic code, say, although I think that's very unlikely given billions of years for evolution. On the Earth, life arose very fast after the planet was formed. So let's choose F sub L, the fraction of suitable worlds in which life does arise, as a half. In that case, the total number of planets in the Milky Way in which life has arisen once is 100 billion times 2 times a half, or again, 100 billion. 100 billion inhabited worlds. Now, the estimates get tougher. Many individually unlikely events had to occur for our species and our technology to emerge. On the other hand, there might be many different roads to high technology. Some scientists think that the path from trilobites to radio telescopes, or the equivalent, goes like a shot in all planetary systems. Other scientists disagree. Let's take some middle ground and choose F sub I as a tenth and F sub C as also a tenth, meaning that only 1%, a tenth times a tenth, of inhabited planets eventually produce a technical civilization. If we were to multiply all these factors together, we would find 100 billion times a tenth, or 1 billion planets on which civilizations have arisen at least once. Now, what percentage of the lifetime of a planet is marked by a technical civilization? The Earth has harbored a civilization capable of radio astronomy only for a few decades, the last few decades, out of a lifetime of a few billion years. It's hardly out of the question that we might destroy ourselves tomorrow. If that's a typical case, then F sub big L would be a few decades divided by a few billion years, or 100 millionth, a very small number. And then big N would be a billion times 100 millionth, or N maybe just 10 civilizations, a tiny smattering, a pitiful few technological civilizations in the galaxy. But civilizations then might take billions of years of tortuous evolution to arise and then snuff themselves out in an instant of unforgivable neglect. If this is a typical case, there may be few others, maybe nobody else at all for us to talk to. But consider the alternative, that occasionally civilizations learn to live with high technology and survive for geological or stellar evolutionary timescales. If only 1% of civilizations can survive technological adolescence, then F sub big L would be not 100 millionth, but only 100th. And then the number of civilizations would be a billion times 100th. The number of civilizations in the galaxy then would be measured in the millions. Millions of technical civilizations. So, if civilizations do not always destroy themselves shortly after discovering radio astronomy, then the sky may be softly humming with messages from the stars, with signals from civilizations enormously older and wiser than we.